Hi, I'm Warren Miller, and I'm going to show you a little bit about filing crosscut saws today. I learned many years ago from a master filer by the name of Martin Winters from Olympia, Washington, who started filing, I believe, back in 1927 and filed for the big logging camps on the West Coast. And when I met him, he was retired and was still filing for contest sawyers. He was a very gracious person to pass on this information to me, and I would like to follow in that tradition and pass some of the skills that I learned from him on to you people. It's been an interesting journey for me, and I hope you have as much fun as I have. The basic way a saw cuts, and the reason you have to put set in a saw and make the rakers a little bit shorter, has to do with the basic characteristics of wood. What I have here is a diagram of a saw in wood with a cutter tooth leading the raker and then a shaving coming up off of the raker. The swedge is shown so that you can see how the swedge actually lifts the shaving up. Now, when the cutter teeth goes over the wood, it's penetrating the wood, and because of the pressure on it, it also depresses the wood. The wood is resilient in nature. You can see how the wood is actually being depressed, and then when the cutter passes over, it springs back up again. And the raker has to be as much shorter as the wood spring back is. And this is shown on the diagram here. This line is the height of the raker, and this white line here is the height of the cutter tip. And if the raker tip were the same height as the tip of the cutter, then it would be pulling whiskers that are this thick here. So depending on the type of wood, consequently the amount of spring back that you get, that determines how much shorter your raker tip has to be than the cutter tip. And as for set, the same thing happens, that because the saw tooth is a wedge, it causes the wood to go sideways, and then when the tooth passes on, that wood springs back. And if you don't have the saw set a little bit wider than the thickness of the saw, that spring back will cause the saw to bind. You need to have a clean saw for a number of different reasons. One of the primary reasons is that when you're running your tools over the saw, the rust on it is pretty abrasive. And if you don't take the rust off of it, you'll wear your tools out pretty rapidly. A saw that has rust and pitch on it will tend to bind in the kerf. Another reason that you want a clean surface, a flat surface, is that when you're using the spider on the saw, which is a tool that looks like this, when you put the spider on the saw, if you have bits of dirt and pitch on there, it'll end up resulting in having a mismeasurement of your set. Normally, what I end up doing for cleaning is that I use an axe stone, which is just a round stone, and I'll liberally douse the saw with some sort of a solvent. Normally, I'll use a petroleum solvent because if you have pitch on the saw, the petroleum solvent will cut the pitch and make it easier to do your cleaning. The reason for using a fluid at all is that if you don't, the pores in the stone will end up plugging up pretty quickly, and your stone won't cut anymore. Okay, so now we've got this saw laid out here, and I'm going to be using a kerosene solvent to clean the rust and pitch off of it. So in order to do that, what I'll do is go ahead and put on a pair of goggles in case I get any splashing from the kerosene, and a pair of rubber gloves to keep it off my hands. Generally, with the stone that you haven't used before, it'll be pretty dry, and so it's a good idea to put a little bit of kerosene on the stone to get it soaking up I can put the stone up here like this and let the kerosene soak into it. And then I'll just take kerosene and liberally douse the saw like that. And with the stone, I just spread the kerosene around so that it will start softening any pitch that might be on there. And then I'll start at one end of the saw generally, and with a good firm pressure on the stone, making sure that you keep your fingers up above the surface of the stone so you don't get your fingers into the teeth. Just a flat pressure on it. I'll start working back and forth on the saw like this, and just removing the rust and the pitch. It's important that when you're using a stone like this to get up and clean the teeth themselves, but make sure that you don't actually get up and take metal off of the cutter tips, because what that'll do is that it will actually reduce the set that's in the saw, and it'll shorten the teeth. So clean up to the tips, but don't actually take metal off of the tips of the teeth. There are numerous different solvents which can be used for cleaning a saw. The primary purpose for using the solvent at all is to keep the stone free from the rust, and also to dissolve any pitch that might have gotten stuck to the saw last time it was used. So you can use kerosene or diesel, or you could use WD-40. You could use turpentine probably. Any of those solvents would work pretty well. With a saw that's rusty but doesn't have any pitch on it, there's no reason that you couldn't actually use water, because again, the primary reason for using a solvent is to cut your pitch. Now clean your rakers quite well so that they're shining. And the reason for that is that a lot of these saws you'll have to heat treat later, and you can't do a good job of heat treating them unless you have a good shiny surface to watch the colors run. So you notice I'm keeping my fingers up on the stone, so there's no chance of getting my fingers mixed up with the tips of the cutter teeth there. Now again, I usually like to run the stone the length of the saw, and even when I'm doing the rakers and the cutter teeth, rather than going up and down the teeth, because going up and down the teeth will leave vertical scratches on the saw. You may be able to see some in here where this has been previously cleaned with a stone whose action has been up and down. You can see that the scratch marks in it. Try to use the stone back and forth the length of the saw like this. These axe stones generally have two different grits on them. There's a coarse grit and a fine grit. I almost always use the fine grit just because there's less likelihood of scratching the saw. If I have a saw that has a lot of rust on it, it's a seriously rusty saw, I'll end up using the coarse side just for the initial work to clean the worst of it off, and then I'll use the fine grit. But I really prefer just using an axe stone like this, or a substitute if you don't have an axe stone is actually to use a rectangular carborundum stone like this. That will work pretty well, just using the same procedure as the axe stone. It doesn't fit the hand quite as well, but it's quite satisfactory. Because this is a fair amount of work, I mean, it does take quite a bit of elbow grease, especially if you've got very much rust on the saw. And so there's a great temptation to use power tools to take the rust off, like an angle grinder or power grinder, or even a belt sander. And I generally discourage people from using a tool like that because it's very easy, especially with a belt sander, to get it up over the tips of the teeth and really remove material from the tips of the teeth. And that can not only shorten the teeth, but essentially put a reverse set in the tooth, which is very, very difficult to take out. One of the issues with an angle grinder or a rotary grinder is that unless you move the tool evenly back and forth on the surface of the saw, it's really easy to make dig marks in it, to actually dig right into the surface of the saw and put divots in it. So if you're using a power tool like that, either a belt sander or an angle grinder, be really careful to stay away from the tips of the teeth and use a fine abrasive so you don't unduly etch or scratch the surface of the saw. Once I've cleaned the saw, the next step in the process is straightening the saw. And you'll find that a saw, even from the factory, is not completely straight. And we want to make sure that it is, because if the saw has a little bit of a kink in it, as you run it through the kerf, a little bit of a kink or a bump in there is going to cause friction in your kerf and will cause the saw to run roughly and bind. Another reason is if you're using a saw with one person or single bucking with it, if it has a kink or a bow in it, on the push stroke, it'll tend to buckle on you a lot more than a straight saw will. And the third, and perhaps even more important reason that you want a straight saw is if your saw has a little bit of a kink in it and you put your spider on there for checking the set, the spider will measure differently if there's a kink in it or not. And the result of that will be, if you set your saw to the adjustment of the spider, that your set for each individual tooth will be different, which is important to avoid. You want the teeth of the saw, your cutter teeth, to all have the same set. So those are the primary reasons that you want to make sure that your saw is straight. Now, normally what I'll do when I'm doing a pre-test or just doing a once-over on a saw to see if it's straight or not, I'll hang it by my finger from a raker and I'll look right down the saw, like this one, looking right down the spine of the saw or the back of the saw, and that will show up any gradual variations or large bows in it. And that'll give me a good preliminary idea of what I'm going to have to work with in straightening the saw. Using that method probably won't show up small individual bows or variations in the saw. And to do that, we'll test for those using the straight edge, which I'll go into here in a second. Okay, once I've done a pre-look at it like this, then I'll hang it up vertically on some convenient place. And what I end up using is just a nail. And one of the important things about the support is that it let the saw hang freely, so it doesn't have any sideways torque on it, which in itself will put a little bit of a bow in the saw. Okay, once I've got the saw hung, then I need to go over it with the straight edges and determine more precisely where the bumps and the curves are. Now, when I was looking straight down the saw, as I did previously, I had a pretty good idea that there was something serious going on in this part of the saw right here. But I don't know for sure what the shape of it is. I can see what the shape is on the back of it, but it's a possibility that the kink or the bow in it is not going straight across the saw. It may be diagonally to the saw in one direction or another. And the only way of really seeing that is by putting a set of straight edges on it. So I take two straight edges like this, and I put one on either side of the saw, and I'll move it up and down the saw like this. And by rotating the two straight edges this way, I can get a tactile feedback from it. A bump on the saw here, and consequently a depression on this side. The straight edge, which is riding on top of the bump, will rotate very easily, and the one that's on the straight edge that's on the other side of the saw will rotate with difficulty because the ends of the straight edge are in contact with the saw, whereas the one that's riding on top of the bump, it's pivoting in the center. So I can get a lot of feedback just by the feeling of it. Another thing that I get feedback from is looking between the saw and the straight edge. For example, this particular bend here, if we get up here, we can see that there's light under this particular straight edge in the center, and on this straight edge that rocks, there'll be light under either end of it. And of course, another feedback that you get, or indicator, is that the straight edge, which is on top of the bump, will rock. So generally what I do is go up and down the saw like this, and I'll start working on the worst bumps first. This bump right here is by far the worst one. So now, once I've located a bump, what I need to do is figure out what its orientation is. And by that I mean, does the kink or bump go straight across the saw, or is it at an angle? Because if I just place the straight edges on the saw in one place, the natural inclination would be to say, okay, I've got a bump here and it goes straight across right underneath this raker, but in fact it may go off at an angle. So I need to go back and forth the width of the saw to determine the direction of it. So what I'll do, I'll start off, say, at the tooth edge of the saw and say, okay, the high spot here, this part of the saw is right here, and then I'll move back and I'll follow it towards the back to see what the shape of it is, or the direction. Well, this one is running just about right straight across the saw, just about the same location as this raker here. Okay, now in my mind's eye, I'll make a mark on it, or often I just put my finger on it here to mark it. If you need to, you can take a grease pencil and make a mark on it, or you can even spit on it and make a mark on it like that, where the kink is. Okay, once I've done that, then I'll take the saw down and put it on the bench on the anvil and start hammering it straight. Okay, once I have checked the saw for straightness with the straight edges, now I need to actually do the hammering. Now for a hammer, what I use is a sawmaker's cross peen hammer, and it's a specially built hammer. As you can see, the axes of the faces are different. They're 90 degrees from each other. The axis of this one is in this direction, and the axis of this head here, or face, is 90 degrees to that. And these are ground such that it's got a sharper radius of grind in this direction than it is in this direction. And what that does is that it bends metal in the direction of the short axis. So it will tend to bend metal this way. And the reason that's important is you need to bend the kink reverse to what it actually currently is. In order to do that, you need to have the axis of the short radius parallel to the axis of the kink, which means that when you hammer on that, it's bending, it'll bend the metal this way, but not this way. Substitute hammers can be used. What I used for several years was actually a 3.5 pound, what's called a single jack hammer, just a standard small short-handled sledgehammer type thing. But the difficulty with using a hammer like that for straightening saws is that rather than having a face on it that has two different radii grind, they're in essence a spherical grind, so that when you strike the saw, it will not only bend metal in this direction, but also in this direction. And so the upshot of it is, if you have a kink here, you hammer it in this direction, you will also tend to put a bit of a dish in the saw, so what you have to do is turn the saw over and hammer that dish out, so you end up having to work back and forth. It's a much more difficult, time-consuming process than using a cross-peen hammer. So to do the actual hammering process, I want this as flat as possible on the anvil as I can get it. And what I do is I just put some supports under either end of the saw, like so. And this is a very loud process. You definitely need to have hearing protection. So what I'll do is strike the saw a number of times along the axis of the bend, and then I'll hang it back up and check it again with the straight edges. Now, one thing that's very important when you're using a hammer like this is that you keep the axis of the hammer perpendicular to the saw, because if you don't, it's very easy to hit the saw with one of these corners and actually put a dent in the saw, possibly even cracking the saw. So you need to be very careful about how you hold the hammer. It's perpendicular. And when I'm using the hammer, I'm not really pushing down on it hard. I'm pretty much just letting the weight of the hammer do the work. If you have a kink that is pretty significant, you can use stronger blows to speed the process up. If you just have a very small kink in there, then you use fairly light blows. And I usually start from the toothed edge of the saw, or where the gullets are, and move towards the back of the saw. Depending on how much of a kink I want to take out, I may use just 3 strikes, like 1, 2, 3, or I may use 4 strikes, like that, to get more hammer action in there. Now, with a saw that has a fairly sharp kink in it like that, that's quite easily demarked, you're only working in a very narrow area of the saw. But if the saw has a large curve or a bow in it, which can happen if you have left it bent over a saw pack for some time, or bent it quite sharply for transport, you may end up having a section of the saw that's several feet long, in which case you have to hammer the whole saw, where you'll actually, say you've ascertained using the straight edges that your kink starts down here, then I'll actually start down here and take a number of light strokes. So I'll hammer, say 3 strokes, and another 3 strokes, and then move the saw a little bit, and do this sort of thing, and work up the whole saw up to the termination of the bow in the saw. Once I have done my initial hammering, there's a good chance that I haven't taken all of that kink out of there. Well, I'll have to hang it back up again and test it again with the straight edges. And this is it's a process that may take 3, 4, 5, 6 times to get that saw straightened out. So I'll hammer on it a little bit and put it up on the hanger, test it with the straight edges, and then find out how things are, and then I'll bring it back, lay it back on the anvil, and hammer it some more. I'll use a pair of short straight edges. These are just 6-inchers, and instead of using them vertically on the saw or along the axis of the saw, I'll do it across the saw like this, with the straight edges extending beyond the tips of the teeth. If I have a raker that's bent, it will hit one or the other of the straight edges. Normally, a raker will never touch a straight edge in a situation like this. Another thing that will, as you're running up the saw like this, that you check for is a bent cutter tip. Because of the set, each cutter will slightly hit the straight edge, but if you have a cutter which for some reason is bent considerably out of line, you'll become very quickly aware of it. It just hits the straight edge a lot harder. Here's actually a tooth that's hanging up more than the rest of them were, so this one is bent out of line a little bit more than it should be. If you go on up the tooth, or on up the saw, there's another one which has a little bit more set than the rest of the teeth. Okay, that looks pretty good. So this particular saw, I'm pretty satisfied with. If I have a tooth that has a lot too much set in it, it's very difficult to take that set out with the normal set adjustment procedures of using a hammer, a small hammer and a small anvil. What I'll actually do is, using the large straightening hammer and the large anvil, there's a lot less chance of breaking a tooth. It's a much easier process to take a lot of set out of a tooth than with a small hammer and an anvil. When I was initially doing the testing of the saw with the short straight edges, and if I were to have determined, for example, that this raker had a serious bend in it this direction, so that as I run the straight edge across like this, I find that this raker is bent this way, and hitting the straight edge, then what I would do, I'll actually turn the saw over so that the convex side of my bend is facing up. That is, the raker tip is actually pointing down at this point. Then I'll actually take the hammer and I'll hammer it here so that it will straighten that tooth out. And then check it with the straight edge and see what the reaction of the hammer is. And if I had struck it enough to straighten it out, then I'd be done. You use the same procedure if you find that you have a cutter tip that for some reason has gotten bent out of the line. One of the difficulties in using a hammer like this with a very large face in between your teeth, your hammer face is actually wider than the distance between your teeth, so you have to be very careful about using the center of the face to bend that, otherwise you'll end up damaging adjacent teeth. One of the things that I have often done when I'm working with a tooth that has too much set put in it, I'll actually use the spider, and I'll be talking later in much more detail about what it actually does. I'll actually use the spider on the tooth and run it across, and if it's got too much set in it, of course the tip of the tooth will be hitting the spider. I'll tip the saw over and I'll hammer on this side with the axis of the hammer going this way, parallel to the bend in the tooth, and strike it out that way. Now, it's useful to know just where in the tooth the bend is. Sometimes it may be up here fairly close to the tip of the tooth. Sometimes, especially with a lance tooth saw that doesn't have this bridge in here, it may be clear at the base of the tooth. And it's important to strike where the bend actually is. And you can tell by putting a straight edge on the tooth and rocking it back and forth, and it'll quickly tell you, just where the bend in that tooth is. You may end up running into situations where you've got a little bit of just a high spot kind of in the center of the saw. And that can be pretty well reduced or taken out by hammering just in the area where that bump is. You use the face of the hammer that has whose axis is parallel to the long axis of your bump. Generally, the bend in a saw is where it's been bent sharply for some reason, and then it hasn't returned to its original shape. So what you're trying to do is just bend the saw back into its proper shape. What is helpful is to have an anvil which is relatively soft. It has some give in it, so that when you hit the saw with a hammer like this, the anvil behind it actually gives a little bit and allows the metal to bend. And so what I find works really well is an anvil which is made out of mild steel. This particular anvil is made out of a piece of 2-inch plate, weighs about 40 pounds. And so I found it works very well for taking the bend out of a saw. I, for a number of years, ended up using a standard shoeing anvil or blacksmith's anvil. And that worked pretty well for me. It has, of course, a hardened, chilled face on it, but in spite of that, I found that it would work pretty well. The one thing that I found that you have to be really careful using a blacksmith's anvil is a lot of them have a pretty marred surface to them, and just from the blacksmith work. And in order not to damage your saw, you need to make sure that you hammer on a part of the surface that's quite smooth. Either that, or you can take like an angle grinder and grind the surface quite a bit smoother, so you have a smooth area to work on.